NMOS transistors? You know how to draw it such that they are planar with each other? I mean, they are right next to each other, etc.
Yeah.
You guys know how to draw. So, what type of dopant do you use in the substrate part of an NMOS transistor? P-type. So, it is that kind of, what kind of dopant? For NMOS transistors, what about the source and drain? What type of doping? N-type. What kind of material should you use as a dopant? Phosphorus or? Yeah. So, okay, so let's see an illustrative example. Okay. So, this is, do you see low cost here or do you see no low cost here? No low cost. Or do you know what I mean by low cost? Local oxidation of silicon, that is lecture 4. Right, lecture 4. Why do you say there is no low cost here? There is SiO2 here. Yeah. So low cost is when the oxide is grown on top of the substrate and when it is capped with silicon nitride. Normally the SiO2 would be into the wafer. Here all the SiO2 is sticking out. So this is the surface oxide based process flow. Okay, that means you had, when you were fabricating it, you grew SiO2 on top, then patterned it and formed it. While for a low cost process, you would have silicon nitride and then you grow in the open areas the oxide. Okay, so you should know, you should be able to identify the structure. Okay, so where so this is the one NMOS, this is another NMOS. So let's say this is like an inverter kind of architecture. So the two transistors are connected to each other through a metal. Where do you think the parasitic transistor will form?
Below your head.
Below my hand? Yes. Which is what? Here? Here? Where? Where would it form?
Below the
With this oxide. Okay, we are talking about how this transistor and this transistor communicates with each other. By right, we don't want this transistor to communicate through the bulk of the wafer. You want them to act as separate. But you could have a channel forming over here. So, what kind of channel am I trying to prevent? P channel or N channel? N channel. So, if I have to prevent an N channel here, what kind of doping should I do? P-type doping, right? Okay, let's think about it. Okay, so the reason behind channel stop is, let's say, you have an accidentally high enough voltage being applied. Okay, so this is an accidental positive voltage being applied or some noise in the system which results in the formation of positive oxide. That positive oxide, positive voltage can accumulate electrons. Why? Because we still have a thick SiO2 here, so you have metal, semiconductor, metal, dielectric and semiconductor. In our transistor, again we have the same configuration. Remember, metal, dielectric, semiconductor. So over here we make a small gate oxide, etc., such that the voltage is very low for us to operate. This is our parasitic one, which is a transistor that forms even though we don't want it to form. Okay, so because it is a thicker SiO2 over here, would the operation voltage for this transistor be higher or lower than this transistor? Higher, right? Because it's a thicker dielectric material, so you need to have a higher voltage to accumulate more number of carriers. Okay, so now if I want to make it even harder for this transistor to switch on, what should I do? I should make the voltage even more higher to turn on. Got it? So if I have to make the voltage even more higher to turn on, I should make it more P-type. So since it is more, if I make this more and more P-type, it is harder for me to attract the electrons at that location and therefore harder for me to turn this on. So in order to switch this off, my channel stop will have to be boron or phosphorus? Boron, which is a P-type dopant. Are you clear, man? You guys all clear? What about you? Okay. Anything doubt, any clarifications required? So they cover the important should be able to draw a structure like this. You should be able to identify the processes. This is the surface-based insulation, not a low-cost insulation. You guys should be able to know what type of dopant you use. If I change this to say, okay, now make sure you have hot electron protection in this structure, how would you modify this structure? Let's say I change the question. Channel stop. The transistor should be CMOS. You should know how to draw. Channel it should have hot electron protection or hot carrier protection. How would you modify this? Yeah, you would add LDD. Yeah, the source and drain would not be like this. You would have an N minus at the interfaces here and here, such that it slows things down. Okay, so because you have been exposed to so many different categories of the cross section, etc., you guys should be able to observe the differences and modify and draw as needed. Okay. Okay. Any question, doubt, clarifications? So I may ask you to say, okay, make sure you are doing it by a low cost. You should know how a low cost one would look like. Okay. Okay. If okay, can I go on to the next question? Okay. Next question is calculation. So calculators out. If you don't have calculators, install app, whatever. Everybody out, like we have time. Those who didn't calculate, they are going to calculate. Those who calculated, don't create too much noise. Huh?